Couple announcements for just basic things. Let me get my screen up on here for you guys too. Everyone on the stream can see it, but not in class. There we go. No, I need to turn the light off over here. Is that visible enough? People want more lights off? That works. All right. I should be getting a syllabus up sometime this weekend for the rest of the class. I just haven't refined exactly where everything falls yet, so I'm working on getting that stuff out. When I do that, I'll also send out a link to the notes for the classes. Sometimes there may not be a lot in them. I really appreciate the person who took notes and sent them out as well, because I want to do a lot of sort of live hands-on assignments in class or working through things. So my notes for any given class might just be reminders about what we're going to be working through hands-on in class versus actual notes of all of the details of it. But when I get out the syllabus, it'll also include a link to a GitHub repository. I should have all that information on it. Basing it off of one that I used for a previous class, so I want to go in there and reorder it a little bit, clean it up before I send that stuff out. We probably won't have any real coding assignment from today's class because we're just getting into things. And it would be hard for me to do any grading or anything else on the programming that you guys will be doing out of today. After today's class, we will start doing hand-on coding assignments and work that are coming out of the classes. And I'll be communicating those both. That most of them will probably be in that same place where the class notes are, but I'll also be communicating those through Slack. So let's get started for today. I wanted to, even though I can guarantee I'm not going to remember everyone's name, but I wanted to have everyone go around again at least one more time and do a quick introduction. Just your name and what's, I don't know, one of your favorite places to eat if you eat out, or if you make a dish that you really love, what's one of your favorite dishes that you like eating? So for me, let's see, I mean, Jared Sirla, and the place I really like is Guasaca. I don't get there very often, but it's delicious. You want to start?
Sure. I'm Carolyn, and I really like to eat at those tapas. Really good downtown Main Street.
Yeah.
Hi, my name is Connie, and I love Mexican food, like anywhere.
Hi, my name is Shu, and I love to eat all the night shoe.
Nice.
So my name is Osvaldo, and I like to eat at Toro.
Hey, my name is Claudia, and it's basically what I eat.
I'm Chuck, and I like sushi. Thanks, Erica. I like donuts.
Nice.
My name is Nick, and I like to eat at Noodle Boulevard.
My name is Jade, and I like to eat at Dashi.
My name is Juan, and I eat food.
My name is Marcus, and I like to eat at Orange Pizza Hut. My name is John.
There you go.
My name is Will. I like eating at a lot of places, honestly. I like eating a lot, but I guess my favorite would be fried.
My name is Michelle, and I like to eat at
Allison. I really love to grill, and so I find
Delicious.
My name is William. I'm from anywhere for a good burger.
Oh, What's your favorite burger place? I'm with you. I'm with you. All right. We're just going around, introducing ourselves again real fast, and then a place we like to eat or food we like to eat. He's like on the spot. Yeah.
I'm sorry, I didn't hear you.
Oh, just introducing ourselves again real fast, and then either a place we like to eat or a food we like to eat or something.
Okay. I gotta agree with them. I really love burgers. It's my first year in the States here, and burgers are pretty amazing. I don't know like a favorite place to eat, but there are a lot of good burgers here. So.
It's very true. Is this helping, by the way, for people to hear me in the back? Yeah? Okay, good. I'm glad. So, not really going to do an active review of the command line, but I wanted to take a moment and see if anybody had any questions about the stuff that we talked about last class, or any questions if they played around in the command line anymore, if they ran into anything that was a challenge for them. Not sure? Yes?
List files. And so I listed the files, and then I said to like get to a file, a particular file when you're in the list. And I couldn't figure out how to change to get to that particular file. And they had a list of like comedies, Marvel, movies, another one, and it said to get to the comedy list. And I couldn't like separate it out, and this is like not what I need to do. And then there might be the list that was under comedy. But I tried to like do the CV space, not that, and put comedy, /. I tried all the combinations, but I haven't.
Okay. I haven't done their tutorial, but I'm going to make some assumptions here, some guesses. It sounds like what they had was something. I'm just going to go ahead and create some structure here that might be similar.
I actually did that. I think it's some files that are actually open, so we try to change directory as far as works. And I think that's like our only thing about is like all
Right.
and touch, and like when you use which.
So touch won't just open a file. Touch updates the timestamp, so it's a way to change a file just a little bit. Really, it's just different programs, right? Like you know how if you're in Windows, you can open a text file in Word, or you can open it in Notepad, or you can open it with WordPad, or any other program that you use for that. It's sort of the same thing. It's just different ways of viewing it. And so if you're trying to view the contents of a file, if you just want to see what's in it and you feel pretty confident that it's not going to be massive, or it's just a short list, then probably the easiest way to just see it is just to cat the contents of it. Because all that's going to do is read out the contents of that file right into your terminal window. Now, if instead it's a larger file, it's hundreds of lines long or something, then I think I might probably got rid of my reference here. Let me try and find a good.
Also notice that the terminal color codes things so that the text or the color directory change directory into a file. So you can only change directory into like that 10 folder. That's another helpful way to figure out what the folder and what's a file.
Let me just find this here. Should be able to get a text version of this. All right, So to copy this, let me see if I can get this working. I don't use this tool all the time. Oops, that is not what I wanted to have copied. Copy link address, there we go. I need to do -O. I need to do -O to open it. Let's see. Is that right? This is me just trying to get this right. URL to work with. Oh, okay. Can't remember how to read it back out very easily. Just getting a larger file to work with on my system here so I can show you. Okay, so URL and then -O for the output. Add it backwards.
Yeah, building command line thing has to
Yep. Let's see if this works. There we go. I think I should have it now. So now if I tried to do cats, this, like, it's massive because it's the full text of Moby Dick. You're not going to be able to work with that. So that's an example where you're going to want to use a different tool because it's a large file. So like less, for example, that's going to let me look at it line by line or page by page. It's just a viewer. So it's just a much different tool that you sort of live inside of. And then, yeah, if you wanted, I don't know if Nano exists on here, but now I'm in an editor. So now I could change the file if I wanted to. Less isn't going to let me make modifications to it. It's just a viewer. Nano is just an editor like Notepad. It just happens to be on the command line. And then it gives me some nice tips telling me how to get out, because otherwise I would have no idea. Hopefully that clarifies that a little bit. Any other questions about the command line? Any stuff that you did on it so far? No? All right. Then we'll dive into some of the material today. We're going to just start touching on JavaScript, but before we get into that, some of you are probably very familiar with some of this background stuff, but I wanted to talk about the general concept of how computers work, how your programming or any program that you write ends up running on a computer. What does it mean to be able to run something on a computer? So your computer doesn't actually understand, say, JavaScript, right, directly. It doesn't understand if I say console.log hello world. The core of the computer can't read this console log statement and turn it and just process it. What a computer understands is machine code, which is very, very low level. Ultimately, it's a series of ones and zeros because it's all just binary on current computers. That's not to say computers have to be that way. For example, I think in Russia at one point they worked on a trinary computer. It had 3 values instead of just 2. We just happen to have standardized on binary computers. But ultimately, everything that you write gets translated down to that level, right? And if you're thinking of it, I always, a little bit of a joke, but always think of it as like the Matrix. It's just this series of completely unreadable stuff streaming through your computer, right? And that's not something that anybody's going to be able to write. So what we have instead are different layers of abstraction on top of that. And what those do is just provide ways for us to write something in a much easier to understand syntax that gets translated by tools down into the machine code that your computer can read. And if there's one universal thing to get comfortable with, it's the concept of working with abstractions in programming, because everything that you're doing when you're coding everything that you're doing when you're trying to reduce the complexity to make stuff easier to work with is just different abstractions. And all an abstraction means is you're basically hiding complexity of something by giving you a simpler interface to it instead of having to worry about all the complexity. An abstraction people work with every day in the real world. A good example is your steering wheel on your car. All you have to do to move your car or to turn it when you're driving is to turn this steering wheel left or right. It's a very simple interface, very easy to pick up and learn. But what's going on under your hood is a lot more. It's got a whole set of gears and pinions and other things that are turning two wheels so that they're turning both the same at the same time. They're staying in sync with each other. There's a lot of stuff going on there, but it's all abstracted over with just your steering wheel. That's the same thing as any programming language. Programming languages are just layers of abstraction. So the first layer of abstraction, once you get above machine code, the one that started out was what's known as assembly language or assembly code. And that's what we have over here on the right side of this is one set of assembly code. And what we have on the left side is a C or C++ program that is accomplishing the same thing as this little bit of assembly code over here, right? Now, ignoring the fact that we don't know how to read C or C++, out of these two, which one do you think is easier to read at some level? The C++, right? Here's let me find another example I've got here, which is we wrote hello world. I just wrote it again over here, right? Where that's our hello world program. Here's an example of a similar hello world program in assembly language, right? This is not easy to read, but you could, if you look at it long enough, if you see these things over here, those are just explanations. Those aren't actual code. That's just explaining what the code does because it's hard to read. But if you look at it long enough, you might be able to start seeing some things that maybe, okay, I might be able to read this with enough time, right? There's some add going on. I don't know exactly what this push action is, but you know, it has to do with something. MOV, maybe that's moving something around. And then you can see down here, here's our bit of data, our actual hello world being put somewhere. Still not easy to read, but a heck of a lot easier to read than ones and zeros would be that you would have to translate into this. So this is the next level of abstraction moving up, and not everything gets directly translated to machine code or to assembly on a computer, but everything does ultimately get down to machine code. And usually what happens is for most programming languages is they take this assembly language, this assembly code, and compile it down to machine code when the computer is running. So it sort of does that almost internally. It links it down or uses a linker to perform that action. And this is an example of what's happening when that's going on is you've got this assembly language code, and then it knows how to map that. It's almost just, they're more complex than this now, but at least when it started, it was sort of just a direct mapping table. It was like, oh, add just means 55H, because those are the machine code instructions on this specific system. And so if you wrote something in assembly language, it could almost directly map down to that. Now I'd say though, that assembly language still, and we already saw in the other example, not easy to read, right? Challenge, it's hard. So we've put layers of abstraction above that to make it much easier to read. An example of that is this hello world in our JavaScript. JavaScript is an example of a higher level language above assembly language that's a heck of a lot easier to work with and read. And when we have these languages, then it no longer has this almost direct mapping that the sort of assembly language had into machine code. because we're no longer just making it easier to read. We're actually changing the structure of how we put stuff together. So this isn't just an easier to read version of add something directly. Instead, it's a real different construct. And in order to convert this down into assembly language or machine code, there's two main paths or solutions that we have in the software or programming world to accomplish that. One of them is what's known as a compiling language. And the other major path that we take is interpreted. Now, these aren't as clean as they used to be. It used to be a really strong separation between the two. But the major difference between the two is that when you're working in a compiled language, what you'll do is you'll write out a whole program at once, and then you'll run it through what's known as a compiler. And that's a tool that at that point translates all of your code into assembly language, machine code, and something that can run on your computer. And when it's doing that, it's having to analyze that whole program all at once to figure out what to do. So it may not, it may be able to give you some useful characteristics where, since it's analyzing all of the program at once, it'll catch errors that are down at line 100 related to line 20 because it had to parse everything and figure out all of this together. The other major path that exists is what's known as an interpreted language. And at least historically, JavaScript is an interpreted language and not a compiled language. What that means is JavaScript historically is interpreted line by line and converted line by line into code that can execute on your computer, instead of having to have the whole program or the whole thing written out at one time. Now, that has some nice benefits, and we're going to dig into that in just a minute. I might switch the order of this a little bit, but that has some nice benefits in giving you some nice tools to help you out with learning and with just faster development cycles. But it can also have some drawbacks, because if it's a truly interpreted language and it's reading it line by line, then if you have stuff down around line 100 of a program that affects line 20 and is wrong, it's not going to be able to give you as much information about that, be as informative, give you as much guidance about what's going wrong. So it's a set of trade-offs with interpreted versus compiled languages. Another drawback that can exist with interpreted languages is, you can imagine if you're compiling a whole program all at once, then the program that does that translation can do a lot of optimization. It can see a lot of things that you can't see if you're reading it line by line. When it's compiled at all, it might even see, oh, you thought you were using this block of code, but that's never used. I can just throw that away, right? Or, oh, this block of code is used in all these places and it's very inefficient. I can spend some extra time making that a more efficient bit of code and faster. Well, if you're purely interpreted, it can't really do that for you. So that's one of the drawbacks of an interpreted language. But again, the pros are some of these other behaviors. One of the big pros that we get, and this is me skipping down, and then we'll come back up and talk about the different JavaScript interpreters that you guys will interact with very commonly. And then we'll talk just about JavaScript in general. But one of the biggest pros is it gives you access to what's known as a read-eval print loop. You'll commonly see this called a REPL. Yes? All right, let me see. That's horrible. I should be sharing my screen. It must have stopped. All right. Hopefully, thank you. So a read-eval print loop is just a program itself, but the name is really esoteric. It's from ages ago, but all it means is it's a program an interactive program that takes the following steps. And you'll see where the read-eval print comes in. If you just look at the first letters of these down here, is it prompts the user to input a line of code. Then it reads the line of code. that you put in. Oops, step back over here. It evaluates the line, in other words, executes that line of code, prints the results of executing that line of code, and then goes back to step one, prompting the user for another line of code. And you guys have already seen this inside of Cloud 9 if you looked at this immediate tab down here. That's just a read eval print loop of Node. It will just read a line of code line by line. So in this case, I'm cheating again. I'm using the up arrow because it even works inside of Node. Let me type it out. So what it did was it read this line of code. It executed it. And when it executed it, that's when it actually printed hello world here. Then it printed the results, which is weird. That's what this undefined actually is printing the results of executing that line of code. And I know that's a little confusing because you're thinking, wait, didn't the hello world was the result of executing the line of code. Over time, this will make some sense, but what's actually happening is this call to console log is actually returning a value, and it's printing that value. The value it happens to return is just undefined. It's not really a value. And then it prompts again for another line of code. So this is one of the major benefits that you get when you're working in interpreted languages. Again, this line has gotten blurred a lot. So things that have traditionally been compiled languages do have some of these capabilities now, but it's a very complex process to enable that on those languages. It's not as easy as an interpreted language where it can just read the code line by line and go ahead and print that stuff out. So now that we've talked about just what a read eval print loop is, let's talk about the two major ones that you guys will probably be interacting with both in this class and especially outside of the class as well. So in the class, we'll be working with Node and the Chrome DevTools console, most likely. You can use a different console if you like Firefox or something else. Node is the one that you'll be working with the most inside of Cloud 9. That's what this immediate JavaScript tab is. And if I open another tab, I go over to just a regular terminal window. If I want to get that same read eval print loop or something very similar, it may have a few minor setting differences. I can just run Node without giving it a file to run. And what it actually does is just opens a read eval print loop. So now it's just in this exact same interactive mode. And we can give it commands to run or code to run over here. And you see this very, very similar, right? This is one of the best places to just play around. Just essentially learn how the programming language works by just throwing commands at it and finding out what it does, right? That'll be some of the stuff that we'll do in class too, is I'll just have you guys write some code or make a guess as to what code's going to do. And the reason you do that is to try and refine your mental model of how the programming language works. And when you're making a guess, you're building a mental model of what do I think this language does? Then you'll run the code and you'll find out, was my mental model right? In which case, okay, I probably don't need to adjust it. Or was I wrong and I need to make a change to how I think the language works and what it's doing. So we're gonna be working in this a lot, but another really useful place is the one that's built into the Chrome DevTools. So one of the great things about JavaScript, the reason we're using it in this class as the language to teach is not that it's the easiest language to learn. It's by far not the easiest language to learn. There are ones made specifically for teaching, specifically for teaching the concepts of programming, etc. But the benefits of JavaScript include it is arguably, but I think there's a pretty solid case to be made that it is the most used programming language in the world. And one of the big reasons for that is because it's the programming language that your browsers understand. So a web browser, whenever it's executing stuff on inside of the browser, it's most likely JavaScript because every major browser supports running JavaScript. they may have their own languages that they can read as well. For example, Internet Explorer used to support a language called VBScript that it could read, but JavaScript has pretty much won that battle. And by doing that, it's become one of, if not the most dominant languages in the world, just because most software is delivered through websites nowadays, which means most software is running some version of JavaScript on there. The other big benefit of learning JavaScript, beyond it just being so heavily used, is since it's used for the web and the web is such a popular platform, it gives you a lot of very direct capabilities on the web as opposed to having to build out applications in a less direct way. And so if we're going to open the Chrome DevTools, if you want to open a Chrome tab, you can do this in Firefox as well, but I'm going to use Chrome just as the more common example here. There's several different ways to open these. You can right-click on a page and choose Inspect. That's actually going to inspect a given element on your page. You can go up to your menu and choose, I believe it's More Tools, and open the developer tools, and it'll also show you a keyboard shortcut over there for opening them. So in this case, it looks like the keyboard shortcut is, what's that? Yeah, Control-Shift-I. F12 a lot of times will work as well. So there's several different ways to get into your dev tools. And then when you're inside of them, I'm going to zoom in over here, shrink this if I can, shrink this over here. You're going to have some tabs up at the top. And you may even have something at the bottom, a window at the bottom or not. You can close that if you do have that open. It's just a way to see multiple things all on here. But this is a useful tool because it gives you access to all sorts of stuff going on this page. We'll be playing with this more and more over time. I'm not going to dig into all the details of how these work. But for example, this is the HTML of the web page, and you can sort of see it all right here. And it'll even highlight the portions of the page that are related to that HTML as you're sort of navigating around if you're in this Elements tab. But the tab we're going to look at right now is the Console tab. And hopefully this looks really similar, right? We got a little arrow key or a little caret and a flashing prompt. So if we try this out here, what do we get? It's almost the same as what we just saw in the Node read-eval print loop, right? So this is just an in-browser read-eval print loop for you to work with. One of the nice things about this, again, is if you're not logged into your Cloud9 environment, but you want to play around with JavaScript a little bit, you want to practice some things, you've got one sitting right there in your browser at all times for you to hop into and play with, right? Probably the easiest environment for you to get into and play around with your programming language. It also respects a lot of these keyboard shortcuts and other things, so I just cleared mine using the keyboard shortcut. The up arrow will give me my last command because it's another one of those sort of terminal environments, or at least it simulates it. One of the unique things about this, though, is that this console is connected to the page that you have loaded. So in the Node environment, we don't have a web page. We're not connected to anything specific. This one is actually connected to this web page. So you saw when I did console log, it logged it right here in my console, hence why it's called console log. But you can actually manipulate the web page as well. And we'll get into a lot more of this later. But if you want to do just something very simple, you could do a document.write. And let's say hello world. And I just rewrote the contents of this web page. So it no longer has all the Google content that was on there. Now, if we look at what's actually on the page, all it has is hello world. So now in a sense, we're writing our own web page now. We've started to make changes to a web page right here from inside the console. We're just telling it to write somewhere else. That document.write is a command to write to a different place than the console.log command was. Any questions about that? Yes.
So when you're directly writing Java and this web page, right? Don't you need an HTML file that put it back to that triggers the Java in order for you to see what you write on a web page?
That triggers the JavaScript. Yeah, I want to be too pedantic, but I want to take one moment to say that there is a difference between Java and JavaScript. It's a very unfortunately named language. It was just named JavaScript, honestly, because Java was really popular at the time it was written, and they wanted to piggyback off of that popularity, so they called it JavaScript. And now there's a lot of confusion between them. Java is more of a compiled language. JavaScript is the interpreted one embedded in your browser. Yes? Yes, yeah. So we can talk about that. I was probably going to touch on that a little more later, but JavaScript is the original name that I actually think it even had a different name at first, and then he named it JavaScript by the time it went out because Netscape wanted to piggyback off the popularity of Java. But in order to be standardized, its actual name is ECMAScript. That's its official name of the programming language that we're learning. And ECMAScript is silly to say and not as easy as JavaScript, so it's never really caught on as the thing that you say. Now, the ES5 or ES6 statement is a programming language. Just, languages, spoken languages evolve over time, right? We don't speak the same way that we did in the 1700s if you're speaking English, or even the 1800s, or even just 20 years ago, because now emojis and other language has changed the way that we talk. Programming languages do the same thing, but they need ways to be more strict about their versions or what version of a language you're using. And so for ECMAScript or JavaScript, they've released different versions over time from ECMAScript 1, and they just shortened that to ES1, all the way through eventually, I think it was in 2015, they released ECMAScript 6 or ES6, and then they changed the naming convention as well. So you'll hear it called ES6 a lot. It's also called ES 2015 because now they plan on doing yearly updates, adding enhancements to the language. So there's also 2016, ES 2016, ES 2017, ES 2018. And each one of those adds some additional features to the language. Now your browser, the challenge with that is these are specifications. This says this is how the language is defined now, but it doesn't mean that every browser supports all of those features immediately. They may not have implemented everything around that specification. So sometimes your browser doesn't have support for them, and you have to either wait or you have to use something that converts a newer version of JavaScript to an older version so that you can run it, right? We already talked about compilers compiling down to machine code. It's just compilers all the way down. Just converting until you get to something that you can use. So that's ES5. Any other questions about this right now? There was a question about just JavaScript running on the page, right? Let me clarify some of that a little bit. If you're trying to embed something on your page, you need some HTML to have loaded the JavaScript. I'll show some examples of that later. Right now, this is just sort of a direct connection to the page. So it's letting me run JavaScript dynamically and modify the web page. But if I was trying to run it when I loaded the whole web page, or I'm trying to build an interactive website, then yeah, that's where you have your web page come down and request a JavaScript file, and it's going to be able to run on the page and make changes. And to show a little more, I'm gonna close this. You don't have to worry about all the details of this, but to show you that this is actually, when I do document write, it's actually just putting HTML on the web page, is we can write any HTML that we want in this. document write statement, and it'll render it on the web page. So our hello world is tiny right now, but let's say I want to be a heading. And then I want something underneath it. I don't know. Another portion of HTML. And now if we actually look at what we put on the page, we just wrote HTML right onto the page. So, you know, go have fun playing with some web page, rewriting what's on it. We'll be bouncing back and forth between the Node console and some stuff in the browser through the class because some things are a little more challenging to get up to speed on when you're in Node. It's a little harder to get input and things like that. And it's easier to learn how to do some of that stuff inside of the browser and then eventually move it back into Node. So we'll be working in both environments a little bit. Now if I reload Google, there we go. You can actually see a whole bunch more stuff here in the console. I really encourage people, if you want to just learn about what's going on web pages, you can go watch videos on how these Chrome dev tools work, but feel free to open them up and look at stuff. Look at what the markup on a web page looks like. Look at the console and you'll see I have some errors thrown. Those are probably because I have an ad blocker on and Google doesn't like that. If I turn off my ad blocker, I'll probably, let me try and reload the page, get rid of my errors, right? But those were actual errors in the JavaScript running, like it had problems or it reported errors at least. Yes.
Just real, like, when I was, especially like HTML, just going to web pages that I thought was cool, you don't have a console in the HTML one that's add that little icon that points to a specific element and shows you where you are.
Yeah. So the easiest way to do this to start is if you're like, oh, I really want to know what, I don't know, what this input is. If you just right click on it and choose to inspect it, then you'll notice it actually, I'm going to shrink this a little bit so that I have more space here. So you may not be able to see all the details, but you'll notice it actually jumped me right to that actual HTML element. So that way I didn't have to try and navigate to it. But also, if you look over on the right side, you'll see that it's highlighting it. It's showing me what element I'm working with. So I can sort of walk up and down this. I'm using my arrow keys right now, but you can click it as well if you want. And you can expand different sections by clicking them. But you can see all sorts of different things on your page just sort of by walking up and down this way. And then another way, if you already have these tools open and you want to see a specific element on your page, is there's this button right up here in the top left that says select an element on the page to inspect it. If I click that and choose something, then it'll select that element.
Yeah, so like one of the things that I still do, and I think it's really fun, at a website, you think it's cool or it does something, and like, and you, I mean, like I don't even understand what's going on right now. Like just looking at code and just kind of seeing how it's organized, really, things started.
Yeah, I completely agree. It's changed a lot, but you'll find a lot of web developers who talk about view source, which is sort of like the earlier version of this. You just didn't have all these nice tools to make things easy to see, as the way that they got into web development, because they just went and looked at what's going on a page. Now there's a lot more going on modern web pages. Makes it a little harder, but it's still a really powerful thing to do. I'll just go ahead and take a minute and we'll talk about some more of this, because I was going to not dive into this as much, but since we're talking about some of that, no, it's good. We'll be touching on HTML and CSS over time, but these Chrome dev tools, they give you views into a lot of what's going on. So a general web page, you can think of it as being 3 different portions or things put together. Again, don't worry too much about this right now. We'll dig into it more. But HTML is more or less defining what's the content on the page. CSS is the way that you say, here's what that content looks like. Here's the style for it. And JavaScript is usually on a website saying, here's what happens when I interact with these things on the web page. So here's a definition of some HTML that says, here's my image. This Google logo is a bit of content on the page. Over here on the right of this is actually the CSS. This is the styling that tells it what to do with that Google logo. And these are, the dev tools are amazing nowadays. So you can do all sorts of things that just really make it easier to learn than it would have been before. So if I've got this image and now I say, oh, it says its height is 92 pixels, its width's 272 pixels, maybe I'm going to try and change that. What if I change the height to be 200 pixels? Boom, right? I made it larger. And recognize this is only for this rendering of this page. If I refresh the page, oops, changed over. If I refresh the page, my changes are gone. So you're not really going to be breaking the page if you're playing around with this stuff. It's a great way to learn how the page works. You say, oh, I want to give this a background. So maybe there's some sort of background behind this image. Put a black background behind it. There we go. You can see just how large it is if you look at aspects of it over here. And you can even change some of those values from right in here. If, say, I double click, I can make this 500. There's so much that you can do in here to learn how a web page works, how your browser works, that you could spend. I know I've given presentations on the dev tools at conferences, and there's still every day things that I find that are useful tips or tricks or things I didn't know, and they're adding new stuff every day. So it's just a really, really great way to learn about HTML, JavaScript, CSS, all the aspects of web development. All right. We take if people want to take a short break, they can right now, and then we're going to start talking about JavaScript as a language. I want to give people a chance, 2-hour class. Sort of long to sit down. If anybody needs a break, all right. Yeah. My lesson, I'm going to post those real soon. What's going on is I have lesson plans from like, what is it, a year and a half ago that I'm using and modifying, but I'm going to change the structure and the order of them some. And also I don't really have a good syllabus in there, so I want to get that updated. Plus they have links to all of my old videos, which if people want to watch them, they can from my previous class if they want to like get ahead or watch those videos, but they're probably not going to be the same order or exactly the same as they're going to be this time around. So yeah, I'll get something posted this weekend with all of that. I just want to do a little bit of scrubbing on that site before I send it out. 5 minutes. Just want to give people a chance to step out if they need to. I know a 2-hour class is pretty long. No, I think it's good. I need to find one thing that I feel like I haven't done is bring in enough browser stuff early on in these classes. I've spent too much time like just on the programming language. I'm a computer scientist, right? Like that's what I care about. And so then it can be a little, it's not as exciting as it should be. I think that's one of the things that I don't do a good job of, is trying to keep it exciting by letting people do bigger things than, oh, I'm printing out a number to a console. I'm so excited for coding. This makes my day. No, it gets boring. Yeah. So I really need to figure out if there's a way to, I've never been able to do it, maybe with the new YouTube tools, I need to practice with those. If there's a way to pause a live stream and bring it back, because I want to have a break like this in class, but if I stop the stream, then I have to start a new one and it's a new recording. I want to be able to pause it so that it's not part of the video and then start it back up again. I don't know if it's possible. So, you know, they're recording all of my weird random conversations right now, and Google's going to data mine all this. Step out myself for just a moment. Looks sort of funny there, doesn't it? Math with numbers as opposed to math without numbers. Weird. What is he talking about? Math with emojis. Somebody said, I don't know if it's true, that apparently California is going to allow emojis on the license plates going forward. Yeah, that's what I heard. What? I just figure people are going to get in trouble. I can't imagine having to try to like call that one in as an officer or something. Yeah, I'm following car. It's the winky emoji. I'm not sure. The ice cream emoji. I don't know. All right, I think we have one person still out, but we're not going to be moving too fast right now. So let's start getting into some JavaScript. How's that sound? This is going to be boring at first. I straight up admit that, because we're focused more on the structure of the language, learning these these underlying aspects of it. So at first, you'll probably think, wow, that's what we're doing in a programming language. I can do that anywhere else. But getting these fundamentals right will definitely make it easier when you're building out more complex things in the programming language. You're having to work with more complex aspects. So the first thing to do, you can hop into a Node terminal. You can do this in the Chrome DevTools. It doesn't really matter. Is we can just do basic math. Let's start off doing, I don't know, let's say times, let me do prime numbers. 17 to the prime. And what we're seeing is, you notice this time with our code, we didn't see undefined there, right? We just wrote a line of code, hit enter, and instead of undefined, we get the result of evaluating this statement or this expression. So that's, seems very simple, right? Okay, all we did was just, we put a couple numbers on and multiplied something. But in the programming language, there's a lot going on in order to accomplish this tiny little bit of code. So this, we step back over here, this is sort of combining, oh, I'm missing a new line that I need. Is that gonna fix it? Let me see. Well, now it's even weirder. All right, whatever. So this is using a few different aspects of the programming language, or a few different fundamental things. This is a statement, and you'll see these highlighted. So a statement is just a group of words, numbers, and operators that perform a specific task. That's a JavaScript term, but it generally applies to most other programming languages. Most of them use these sets of terms are pretty general. However, they do have specific different meanings in different programming languages that might vary a little bit. Whereas we also have an expression in here, and an expression is any reference to a variable or value or a set of variables and values combined with operators. And then an operator is how we perform actions, on variables and values. So if we go back to our little bit of code here, our one tiny line of code, what is, somebody want to take a stab at what the operator is on that line of code? What? The multiplication sign, right? Ah, we're used to mathematical operators. That's why I use this, because it's a nice, easy, it relates to what we're doing in math or other things. And this whole thing is an expression, but there are also sub-expressions inside of it. This is a number expression, as is this, and this is the mathematical operator, and the whole thing is also a statement, and the result of evaluating this entire statement gives you this new value. Yes?
But I noticed that you didn't put a semicolon in that line, so what's the deal with that? You always have to put
You should. This is a religious war.
Sorry, I didn't even know that.
So in programming languages, you know, we've got our little wars that we like to fight. Some people, do you indent with tabs or spaces? How many spaces do you indent with? Where do you put brackets when you're putting brackets on things? One of the religious wars in the JavaScript community is, do you put semicolons or not? The truth of the programming language is every statement that you want to have has to end with a semicolon. Well, not every statement, that's not true. It has to end, it's either a block statement or you need to end with a semicolon at the end of your line, essentially. So rewriting this, you can put a semicolon there. I probably tend to not do it only when I am in the REPL environment, the read eval print loop environment, because there can't be any confusion as to where my expression ends. It knows exactly where it ends. I hit enter. Whereas when I'm writing an actual program with multiple lines, I always use semicolons. JavaScript, this is getting into some deep aspects of the language, but JavaScript does have something known as automatic semicolon insertion. So your JavaScript engine, the thing that's interpreting it, will read your code and try to figure out where the semicolons should be and put them in your code. And 99.9% of the time, that's going to do exactly what you want, which is why some people say, oh, you don't have to write semicolons in your JavaScript. You can write it without it, and it's cleaner, and it's not as ugly, and it's pretty. But semicolons are required. It just so happens that the interpreter is putting them in there for you instead of you putting them in yourself. And that one time out of 1,000, you're going to get caught and you're not going to understand what's going on because it put the semicolon in the wrong place and you intended to do something different. An example of that, I can't really show you an example right now without teaching a lot of other programming concepts. But there's a common example of that where you're trying to send back a value and instead you give back undefined instead of the value you want as an accident of it. So
I just asked a question because I think when you guys become more advanced and start collaborating on projects, it really helps to adhere to conventional standards when writing code. The semicolons are a simple thing, but there are lots of other conventions. Like Google has a JavaScript style guide, for example, that I think is adhered to by a lot of programmers, and it can just help when you're sharing code to comply with those conventions. It makes it a lot easier. Like if someone is writing code in their own sort of like idiosyncratic way, it's a real pain to try to like either add to or change some of that code because they're not complying with the things that everybody else is. So
right.
It's probably just a good habit to get into.
No,
most people use a semicolon, especially like when you're writing lines of code. Google style guide actually says that you shouldn't rely on the semicolon insertion.
Yeah. It's a tough one because there's another, I mean, there's several style guides. Like there's an idiomatic JavaScript one that says don't put semicolons in, and that's why I don't like that style guide. But yeah, being standardized is good, right? If you're ever confused as to like why there's value in something like that, think about applying it to just written language or spoken language. Imagine you're collaborating with a group of people on a term paper, and some people put one space after a period, some people put two, some people wrote their stuff using 16-point Arial font, some people wrote it with 12-point Times New Roman, and you're trying to put all this together in a term paper. Some people separated out their paragraph or section headings, and some people put them in line. It's a challenge. It's a challenge to understand and read through the whole thing collectively. And so you're probably going to want to convert it all so it looks the same. It's just better if there's a set of style guides that say, here's how to write your code collectively so that it all looks the same. Just like you'd say, all right, we're writing this paper this way, so as long as everyone's section is that way, it's going to be much easier to put together. Same sort of thing. So, yes?
So when you quote the statement, how is so in my understanding, you have to have some sort of console log, and then the brackets, and then you have the multiplication and the problem, right? For to return a value when you run the command. So what happened here? You didn't write any like.
Let's rewind a minute. So
you write a whole world by itself now without the console log.
yes, yeah, let's do it. I'm going to do it just like this right now, and it's going to give me a syntax error. Let's try that.
What is that?
No, it's a great question. So the console log bit, that's really a command telling it print this out. And you'll notice when we ran console log, that's what I was getting at earlier, we actually have two lines that get printed out here. One of them is the hello world. That's the, if you will, that's sort of the side effect of running console log. It's purely a side effect that says print this out. But then you have the actual result of evaluating the console log statement. And because this is a read eval print loop where it's just printing the result of evaluating each line, that's what undefined is actually the result of evaluating it. So another example would be if I did a console .log and I don't actually pass anything to it, what you'll see is it prints out nothing and then undefined. That's because, and we haven't gotten into functions or how that stuff works yet, but the console log statement just returns undefined as its value. It never returns a different value. Whereas, for example, the direct statement that I wrote right here, it doesn't have any side effects. It's the read eval print loop is evaluating that and then just printing the results of that evaluation normally.
My hope if you do this in an actual file, like the Hello World JavaScript file,
Yeah.
and then write that line, and if you don't put the console log and run it with a node, it won't print that.
I think that's great. So if we come over here, exactly, I'm going to, oh, this is something I totally forgot to put in my notes. It's a very simple thing to pick up. Oops, go away. Very simple thing to pick up, but another really useful thing to learn, one of the first things I think you should pick up in a programming language is putting in a comment. A comment just means this is something that is there for me or another developer to read, but I don't want this to execute in the code. This doesn't do something. So what I'm gonna do here, the way you put a one-line comment in a JavaScript file is you just put these two slashes in front of it. And then everything else on this line is a comment. So if let me uncomment that for a second, just to show you what happens. And now if I run that program, we get hello world. And now if I comment that out and save it and run it, it doesn't actually output anything because it didn't actually evaluate that line. It's just a note for me as a programmer. And usually you won't just comment out a bit of code. You'll put notes in your code that say something like this. This is a little note to myself telling me what my code is supposed to do here. And it's nice and easy to read. And now I know exactly what it's supposed to do. But another common use for comments is to say, I'm not sure about that line. Maybe that's causing a problem. I'm just going to comment it out right now so it doesn't run and do something else. So I left that line in and I commented it out. And now I'm just going to write hello world right here. And I'll put a semicolon at the end. And let's see what happens when I run this. Is I get nothing. No output whatsoever. And that's because Node is executing this program, but it's not in a read eval print loop. So the result of executing every line isn't getting printed out automatically. That's just a nice little thing that we get in that read eval print loop that makes life easy. In this case, it's going to only print out stuff that we tell it to print out to the console. So you can, yeah, the basics here is you've got all your standard mathematical operators that you can do on numbers inside of this. So if we did 13 divided by 3, you get a result out. You can do addition. All of your standard mathematical operators just exist right there. And you can write them inline in this way. But all of those are very, very simple JavaScript programs that could be, in a file on their own. However, going back to what you just said, how is that useful to me if I wrote those in a file on their own if I can't see the results of it, right? How is that useful to me at all? Well, maybe you do a console log here with what you want so that you're going to see the results of it. And now, bring this back up. It doesn't do good when I go to the top. Now you can see the results of running that because we're printing out the result of it. there any questions on that so far? All right. It's pretty basic right now, but I'm emphasizing some of that stuff so that you'll get to thinking about stuff this way. Thinking about statements and expressions and how stuff is composed and operators. If you read your lines of code that way, a lot like if you're trying to break down an English sentence into the different parts of the language, it's going to help you understand what's actually taking place in it. So the next thing I have, just a couple more topics for today. We might finish a little early. Is the concept of types. Inside of your computer, we already talked about machine code. Everything's just ones and zeros ultimately. But it's really useful for us as a programmer and for us to optimize the code that we're writing to have different types of data that we work with. And we've actually already seen 2 different types of data that we've worked with, even in the small examples that we've had so far. Does anyone know what the 2 different types of data that we've seen are? Strings and integers. Integers would be a good one in most programming languages, but the types are not always, but usually unique to a programming language. So the types that we've seen are strings and numbers, because JavaScript, unlike other programming languages, makes no distinction between an integer and a floating point number. They're all the same thing. Floating point, don't worry about that term if you're not familiar with it. But yeah, commands, another command that is built into JavaScript that helps us understand what's going on here is this type of. This is a method or an operator. So if we say, what's the type of 13, it's going to give us a nice string back that says that's a number, right? And just to show you, if somebody's familiar with other programming languages, we did type of 3.333, that's just a number too. In some other programming languages, that would be a float. In JavaScript, all numbers, no matter decimal numbers or not, are just numbers. So that's one of your most basic types. And when you're doing most of your mathematical operations, it's operating on a number, it's expecting a number type and a number type on both sides of that expression. So 13 times 17, this is a number type expression. This is a number type expression. This is the multiply operator, and then it gives you another number type as your output. Does that make sense? And then the other type that we've encountered is a string, and you designate a string in JavaScript with single or double quotes. It doesn't actually matter. And we can see that by doing hello world, for example. And that says it's just a type of string, right? So type of is a nice way to check what the type of something is, although it lies sometimes in JavaScript because JavaScript is a horrible language in some cases. So there's a few cases where it lies about what the type of something is. That's what you have to get used to. We'll cover those when we get there. The reason this matters for types is several different things, but I already said if you're trying to do a numeric operation, you want it to take, like multiplication, you want to use number types. And when we did 13, that was a number. But let's try this. Type of quote 13 at the string. So it's the same characters that we put in, but by putting quotes around it, it sees it as a string and not a number. And that will change the way that JavaScript works with that value. So if we did quote 13 plus 17, we don't get the result of 13 plus 17 added together. We get something that is really weird. What the heck just happened? Because I gave it a string and a number. This, I won't get into all the details of it, but what it actually did here was there's a lot of complex background going on in JavaScript. It looked at this, it tried to figure out what the types were. It said, oh, I'm doing strings. well, I know how to add two strings together. Let me give you a better example of adding strings together. Hello plus world. I just put the two strings together. That's nice and easy, right? I just added those two strings together. So look, the plus operator works on strings. It just does something different than it does on numbers. But with this 13 plus 17 case, it was trying to figure out what to do with this line of code. It says, ooh, I need to add stuff. What am I adding? Oh, it's string. Oh, this other thing isn't a string. Well, maybe I can make it a string. Maybe I can say that it's really a string. So another way to do that would be if I did, it's not going to work that way because it's an actual number and I haven't put it in something. Yeah, if I stored it, I could do this. But basically what it's doing is just converting that into a string. And when it converts it to a string, it just turns it into 17. And then it puts those together using the string addition as opposed to mathematical addition. Now you don't have all those operations for everything. So like not every operator works with that you can't really multiply strings in a logical way. It doesn't really work. But you can add strings. But that's why type ends up mattering, is because it changes the actual operation being performed in different cases. And you can do a lot of different stuff with the different types that you're working with in the programming language. Any questions about just the basics of strings or number types right now? All right. So the next thing is, okay, I can use this as a calculator, but let's say I want to figure out how many seconds there are in a day. All right. So let me say there's 60 seconds in a minute and there's 60 minutes in an hour. So I get 3,600. And now if I do 3,600 and how many hours are there? There's 24 hours in a day. So I have 86,400 seconds in a day, right? Did I do that right? Double checking. It was sort of annoying to have to type this number out again in between. If you're used to a calculator, the calculator usually stores your value and then you can just apply that operation again, right? You can also store values in a programming language. In fact, it's critical to be able to store values when you're programming. And the way that you do that is you put that value into a variable which holds on to it. So the traditional way in JavaScript to declare a variable is using var. That's the command, and then whatever the name of the variable you want it to be. So I'm going to make one here, and it's going to be a long name. Yeah, it's funny that it's longer than typing out 3,600, but we're going to call this variable minutes in an hour. And what we're going to do is do 60 times 60. You notice what we got at the REPL line this time was not 3,600. That's not the result that it spit out. Instead, it gave us undefined. That's because what it evaluated was this entire statement, and assigning a variable into something is going to return undefined. But this expression was still evaluated and is now stored using the assignment operator, that's what equals is, into the minutes an hour variable. Oh yes, you're right. See, I screwed it up. Let's create a new one and we'll throw the other one away. How do I get back to that, like that value? I can see it just by typing out the variable name in the REPL and hitting enter, and it will evaluate. And the evaluation of that is whatever is stored in that variable. So this is a way to store anything that we've done. So let's make it more generic. Let's treat it like our calculator. And let's just create a variable called result. And then we can store anything in there that we want to store. So result has 60 times 60. And now if I want, the interesting thing about this is with most variables in JavaScript, you can use that same variable name and store a new value in there progressively. So in this case, if I want to know how many hours there are in a day, and I know that result currently has, or seconds in a day, and I know that result already has a number of seconds in an hour, then I don't have to redeclare the variable because it already exists. I can say result equals whatever is in result right now times the number of hours in a day. And now if I look at, oh, what did I do wrong here? Let me see. That is way wrong. That is epic. All right. Let me see if I can fix this. I got no idea what's going on now. I'm guessing that this isn't actually letting me, it's not storing my, I can't use result. Okay, so let me use a different variable name.
It's a good lesson though. You don't use predefined terms.
Yeah, well, it's tough because it's not one that's in the language, so it must be inside of this, the REPL that they're already using it because it's not reserved in JavaScript itself. So I'm going to call it something different. I'm just going to call it M for memory, like the M button on your calculator. So now, all right, M is working as expected. And I can say M times 24. And now we see that M is 86,400. And it's also interesting here, if you notice that when I did this variable declaration for M, the result was undefined because that's what got returned. But when I did the assignment here, the read eval print loop actually printed out what got assigned into it. So those statements are not equivalent. They're doing something different with each one. Yes?
Is there a way in 5.9 to view what variables you find in this immediate window?
I don't think so. Yeah. I'm trying to think. I don't think that there's any way to do that I'm aware of. Now, that's a reason in my mind why a lot of times I'll use this space over here and just start up a node interpreter, because that immediate window sort of hangs around for a long time. And if I want to reuse variables or do something different, they'll still be there. Whereas if I go over into this node interpreter, if I just exit out and start a new one, it's like starting with a clean workspace every time. We'll talk a lot more about variables and assigning things into them, but variables are really the way that one of the basic constructs that allow you to create complex programs and build stuff up over time, right? All right, I did a computation, I performed some operation, put that in a variable, and now I can work with that value again and again. And you can. So if we have this, let's go back to storing 3600 in it. I can use this value in multiple different operations. I don't have to assign something new to it. Now that I've got it there, if I want to say M times 24 to see how many seconds are in a day, I can do that. But if I don't assign something new to it, I can say how many seconds are there in a year? Because every time it sees this M, what it's actually doing is looking up the value stored there and replacing it with it. So you could read this line here. Bit by bit in the programming language, what's going on is it's essentially looking at the whole line, saying, all right, what do I have to do? And since there's no change in order of operation does apply the same as any mathematical principle. It will first look at this 24 times 365 because it evaluates from right to left in JavaScript. I'm pretty sure it does. Could be wrong there, I'm pretty sure. So if I type that in real fast, 8760. So now it's going to be processing this line piece by piece. And now it will essentially see that line of code as the equivalent of m times 8760 because it reduced these down to the multiplication of them. Now it sees this line and it says, oh, but I don't know what m is, so I need to figure out what m is. So the next thing that it does is it gets the value for m, which is actually 3600. And that's what it looks like in the next step of the evaluation of this line of code, is it's now has replaced m with the value for m at that point, and then it performs that operation. Does that make sense how it sort of broke it down piece by piece, operation by operation? Yes?
So it doesn't really care about what you set it as. You named it variable n. Then later you say n equals 60. It doesn't care about that.
Nope. Nope. Because I'll pull out a whiteboard real fast, even though people won't be able to see it on the video, but essentially what's happening in the actual memory of your system, more or less, is if you want to imagine you've got a large, just millions of memory locations in your computer to store values. And here is where we're storing this value for m. And what we had before was, I don't know, let's put 60 in there right now. So we put 60 in there, and we say, actually we wanted 60 times 60 in m. Well, m stays in the same place, and it just replaces this in memory. So now this location stores 3600. And so the next time it tries to read m, it just gets the value that's there now. It doesn't know anything about what was in that memory location previously. So another example of that, right, is let's go back up here. And we did m times 24 times 365 to get this. Well, if I change m again, we'll just go back to 60. And I'll reevaluate this exact same line of code, m times 24 times 365. I don't get the same result. And the reason is because it's always reading that line of code, the value of m at the time it encounters that line of code. And so when it ran this line of code, m is now 60 instead of 3600. Does that make sense? Any questions on just the very basic aspect of using a variable like that right now? All right. This variable contains all of the aspects of whatever's in it too, right? So if we did type of m, this is going to first replace this m with the value that is in m, and then perform the type of operation. And so it's got a number in it, right? Just anytime you see a variable in the code, what's going to happen is before it completes that operation or that computation, it's going to replace it with whatever the value for that is at that point in time. Also in JavaScript, and yes?
So when you communicate it and delete all of it, it's still saved.
Yeah.
That m plus number. So how do you get back to a fresh start? You've got so many things that are saved and you don't really keep track of it.
That's what I was saying. I'm not sure how to do it from this immediate window. I guess you can open a new immediate window and that'll be fresh. But that's why a lot of times I'll do it right over here inside of I'll just start node directly instead of using that immediate window, because every time you start node, it's a whole new program and it throws away everything that it knew about before. This is a little bit unique to JavaScript, is when you're assigning variables, some programming languages will only let you assign one type to a variable. So once you have to declare what the type of that variable is going to be. JavaScript doesn't have that restriction. So even though M, the type of M right now is a number, we can put a string into it instead. And the type of M now is just a string because it just has that string stored in it. It's no longer pointing to a number, it's now pointing to a string. And now you can see why it might be a little easier to make the mistake of doing something like 13 plus 17 than you thought at first, because if you look at that line, you go, how would you ever do that? Why would you put quotes around that? Maybe you accidentally stored string in something and you did M plus 17. And so you can't see it just right off of that line, what's going on. You have to understand what's being stored in that variable and how that affects that computation.
So I'm not sure if you can delete all the variables in the workspace all at once, but I know you can delete like a specific variable that you type delete n. So right, delete n, it should.
I'm not.
If you put n now, it should get.
That's weird. That shouldn't work.
Oh, really?
So yeah, it works because of the way that the REPL loop is constructed. But you can't delete variables with the delete command or operator in JavaScript. You can delete properties of objects. This is getting into something that you don't need to understand what I'm saying right now, but you can delete properties of objects, but you can't actually delete a variable. So I'm guessing that the read-eval print loop is actually storing everything in this as a property on an object. And when you perform the delete, it's deleting it off of the object. So you can do it, but it's probably a little misleading to do that.
So you could do that in like a .js file.
You could, but it wouldn't do what you think it's going to do, or at least it shouldn't. So we could test that. You can do these same things. Let's go back to an actual JavaScript file now and sort of show doing some of this stuff here. Let's store our message in a variable. And then let's go ahead and print out our message here. And remember, if you just put your variable there, it's essentially replacing it when it runs with the result of that variable. And so now, if we did, yeah, I might need to zoom back out one notch because it's really wonky with the scrolling right now. So now if we did our hello.js, it'll still print out the exact same thing. We're just using a variable to store that string instead of directly writing it in console.log. So now let's test, because I actually don't know what's going to happen. We're going to find out. Let's try. First off, I'm going to do this. I'm going to comment out this to see what's going to happen here. It should tell me that hello is not defined, because I never defined it. It tried to read a hello variable. It says, there's no variable named hello. I can't read a value out of that. And it gave me an error. This error is ugly to read, but when you encounter errors, the best thing you can do is take a little bit of time and try and read them. You're going to see them. You're going to go, my code's not working. What's going on? And you're going to immediately try and get help, or I don't understand what's happening. This is going to happen forever if you program, all the time. So it's to your benefit if you take a little time, pause, try and look at it, try and understand maybe what it's telling you, and follow those instructions. Because the more that you can learn to read your error messages like that, the faster it's going to be to fix problems that you encounter. Yes?
Okay, just add on to that, like sometimes success is getting errors. So it's you're getting an error, you're like, it's involved in the error message getting error messages, they are your friend. They feel, like to me, they first thing you feel out is like, oh my gosh, why is it? But now I'm just like, oh, it's an error message. Hopefully that will help me figure out what else.
Yeah, that's I love that. The worst thing that can happen once you've gotten more experience with programming is when you have an error in your code and you're not getting some sort of error message that tells you what's going wrong, because you're just like, great, nothing, great. I have to root cause this entirely myself because my code is not telling me anything about what's going wrong. I want it to yell at me and say, no, you tried to assign something that you couldn't assign. Please help me.
If it's really obscure, just copy the error message and Google it. And odds are somebody else has encountered the exact same problem. And there'll be like a help page somewhere on Stack Overflow that will explain what does it mean when it says reference error.
Yes. Always feel free to copy them and just Google it. Like it's your best friend. Google is your best friend as a programmer. All right, let's see what happens here. I honestly don't know what's going to happen, so we're going to find out. It didn't actually delete. What? Because I put a second console log in. I wanted to test this delete.
Looks like it's flagging that line with the red X. Oh, it says it should not be deleted.
Yep. Variables should not be deleted. So it's a little, I guess you can do that in that REPL, but it's a little misleading to be able to do that because normally you can't do that on a direct variable.
It's just telling you that's like a bad we didn't find a variable.
It's because you actually, I mean, you can't really. And so if you ever have questions about that, again, Google. I really strongly encourage you to Google stuff. So like JavaScript delete. What does the delete operator do? It'll tell you right here. The JavaScript delete operator removes a property from an object. All right. I think they even have a note down here. Unlike what common belief suggests, the delete operator has nothing to do with directly freeing memory. It removes a given property from an object. You guys don't know exactly what objects are yet, for most of you, but that tells you a lot about it. Always be Googling, always be asking these questions like, how does this stuff work? Why does it do this? Search it up and read the documentation. Even if you have no idea what it's saying yet, the more you read it, the more you'll start to internalize, wait a minute, I saw that term over here too. Maybe that's related. Maybe that's going to make sense over time. All right. Let me just double check. Yeah. All right. So we've done variables, the basics of variables. One other small thing about variables that I wanted to touch on. So maybe I will be able to give you some very basic coding assignments soon. One other small thing about variables is you don't have to assign it a value immediately. So in this case, m's not defined, right? So if I declare variable m exists now, but it doesn't have a value. So if we did type of m, what are we going to get? That's interesting. Undefined. We'll talk more about that in future class, but that's yet another type. So now we've introduced 3 types in JavaScript. We've got, what are our 3 types that we've encountered? Strings, numbers, nope, undefined. What? That is a really weird type. It is. We'll dig into it a little more in the future, but that just means that it's declared, it's there, but it doesn't have any value that it can understand. And so, for example, if we did that in our code up here, let's get rid of our giving it a value, assigning it a value using the assignment operator. And now we run this. It's going to run just fine, except what it printed was undefined, which is weird because it's not actually it doesn't have the string undefined in it, but it printed it like it is. That's another one of those weird type coercion things where it saw undefined and it converted it to a string of undefined. All right. So what I would say is for practice, if you want to practice stuff, if you're doing any sort of mathematical operation, if you're doing any sort of addition, multiplication, just open up a JavaScript interpreter, whether it's the Chrome DevTools, whether it's the one inside of Cloud9, and do those operations inside of there. Practice performing these operations and doing mathematical operations in there. Practice assigning those to variables. You can give your variables any name that you want, but it's a good idea to give them meaningful names, because as your programs grow, it's going to help convey a lot more about what this variable represents. Like you saw the hello, probably a better name for that is hello message, because now it really tells you something about what this is intended to be. Oh, this is a message of some kind stored in there. Message, probably a string. I don't know for sure, but a message is probably some sort of string that you're saying. But yeah, practice all of that. I would say just get used to it. If you have any questions about it, ask questions. And I would also encourage you to just search up JavaScript operators, and you should get a long list or operator. You should get a good list of different operators. This is the W3 schools. But if you do run across this, and there are some there that you could also find the MDN one, I'm sure, which is a much longer list, more detail. If or when you run across that, and there's ones that you're not sure what they are, feel free to ask a question, because we're going to be digging into some more of them in the next class. Next class, we're going to be digging into comparison operators. How do you compare values and what that results in? And that'll introduce yet another type for us as well. All right. Are there any questions? No? Okay. Well, thank you.